Hello, everybody. This is a quick reading, and I'm going to have you listen to this so that you're getting your listening in. Um, about energy. Okay, so I know Mr. Rife in the conceptual physics class had you do an app that's called Desmos, and I'm going to have another video. I'll put that in conceptual physics, but and it's how to navigate through Desmos because I think it could be a little bit challenging for everybody. But for our listening portion of today, we're going to read about, or you're going to listen to me read about energy. And then this will be a play pause it. So, energy. What is energy? The simplest definition of energy is the ability to do work. Energy is how things change and move. It's everywhere around us and takes all sorts of forms. It takes energy to cook food, to drive, to school, and to jump in the air. Different forms of energy. Energy can take a number of different forms. Here are some examples. Now, I want you to pay attention to the examples here and know that in conceptual physics, there's going to be 7 different types of energy that Mr. Rife will talk about, and we need to remember those. And I'll share with you different ways that we can memorize it. But chemical energy comes from atoms and molecules and how they interact. Electrical energy is generated by the movement of electrons. Gravitational. Large objects such as the earth and the sun create gravity and gravitational energy. Heat. Energy is also called thermal energy. It comes from molecules of different temperatures interacting. Light. Light is called radiant energy. The earth gets a lot of its energy from the light of the sun. Motion. Anything that is moving has energy. This is also called kinetic energy. Nuclear. Huge amounts of nuclear energy can be generated by splitting atoms. Potential. Potential energy is energy that is stored. One example of this is a spring that is pressed all the way down. Another example is a book sitting high on a shelf. Units of measure of energy. For energy. Units of measure for energy. In physics, the standard unit of measure for energy is the joule, which is abbreviated as J. So remember, joule was work. Remember, work, the unit of measurement for work was joule. So energy and work have the same unit of measurement. Probably going to be a good thing to remember when we're doing calculations. There are other units of measure for energy that are used throughout the world, including kilowatt hours, calories, Newton meters, therms, and foot pounds. Law of conservation of energy. This law states that energy is never created nor destroyed. It is only changed from one state to another. So energy is the same amount of energy that was on the earth a billion years ago is the same amount of energy that is on the earth today. It's just being transformed from one thing to another, from one type of energy to another. One example is the chemical energy in food that we turn into kinetic energy when we move. So once we eat breakfast, that changes into energy and then we can use it throughout the day to move. Like we need food to be able to do work, right? And so that's one form of energy, how it's transferred. Later in the unit, we are going to be talking about renewable and non-renewable energy sources, and it just saves the world if we are able to utilize water, and that can be transferred into energy that we can use to power our houses. People, I don't know if you've seen this before, but they have solar panels on their houses, those big black squares that people put on like their roof, and then that they get energy from the sun, and then that powers their houses, their electricity in their house. It's pretty interesting, and it saves a lot of money, and it saves a lot of pollution from happening in the world. But We'll read about it. As humans, we use a lot of energy to drive our cars, heat and cool our houses, watch TV, and more. This energy comes from a variety of places and in a number of forms. Conservationists classify the energy we use into two types: renewable and non renewable. Non renewable energy uses up resources that we cannot recreate. So once we've used it, it's gone. Some examples of this are gas to run our cars and coal burned in power plants. Once they are used, they are gone forever. A renewable energy source is one that can be replenished, so you can reuse it. Examples of this include hydropower from turbines in a dam, wind power from windmills, and solar power from the sun. The more renewable power we use, the better for our planet and for future generations as they run out of resources someday. Here's some fun facts about energy. In 2008, about 7% of the energy used in the United States was from renewable sources. That's not really a lot. We need to be doing better. A modern windmill or turbine can generate enough electricity to power around 300 homes. That's really good. People have used water power to grind grain for over 2,000 years. Geothermal power uses energy from geysers, hot springs, and volcanoes. The entire world could be powered for a year with the energy from the sun that falls on the Earth's surface in 1 hour. We just need to figure out how to harness it. How do we keep that energy from the sun and use it? We haven't figured that out yet. So the next thing that you'll do in science support is reading, and then you'll have a writing and then a speaking. Okay? Thanks for listening.